Hi, welcome back. We're very happy to be here on the Azure Community Conference, and in this next session we're going to talk about Dapr. My name is Edwin van Wijk. I work as a principal architect for a company called InfoSupport in the Netherlands, and I'm also a Microsoft MVP. And today, my colleague Sander is going to help me. Sander, can you introduce yourself?
Yeah, hi, I'm Sander Molenkamp. I'm a principal cloud architect at InfoSupport, and I'm also an Azure MVP.
Great. And we're going to talk to you today about Dapr. And Dapr is a distributed application runtime that you can use to build microservices. And we're going to tell you all about what it is and how you can leverage it in your applications. Many organizations have adopted a cloud native or microservices architecture nowadays. When we look at distributed systems, there's a lot of complexity in there. You have lots of running parts, and it can be really complex to make that scalable and fault tolerant. That's not an easy task. And if we look at the complexity in a system, you can basically say that the essential complexity is the complexity that is inherent to your problem domain, or that is basically the complexity in your business. And this is also where the business value is. So you should focus your attention on the essential complexity that is in your business domain. But we as developers often add a lot of what we call accidental complexity. And accidental complexity is everything that we need to build the system, like infrastructural components, abstraction layers, or data access layers and stuff like that. And basically, we need to focus as little as possible on this accidental complexity and make sure that we offer enough business value by focusing on the essential complexity. Well, this is exactly where Dapr comes in. Dapr can help us to focus on the business logic and not worry about integrating with all kinds of infrastructural components or other systems. And we're going to talk about how Dapr does that in this session. So what Dapr basically is a runtime that offers a couple of building blocks. And you see a couple of them over here. We have, for instance, service-to-service invocation. This is really a nice way of calling other services within your system without needing to know where they are. We have state management for storing key num values or key value pairs into a database or another kind of storage for making your services stateful. We have publish and subscribe. This is publish and subscribe as we know as a pattern, so we can use it to build loosely coupled messaging within our application. There are resource binding and triggers. This is also a way to integrate with all kinds of systems. We have an actor model implementation for Dapr, and basically it's a virtual actor model, but you can build actors with that. There's a lot of stuff around observability in there, so you can monitor your services and have end-to-end tracing and stuff like that to make sure that you know what goes on inside your application. There's a building block for secrets, for stuff that you don't want to, put in your code or in your configuration files. And then you can, for instance, leverage Azure Key Vault or HashiCorp Vault for storing these kinds of secrets. And you also see a block that says extensible. Because Dapr is completely open source, it will probably get more and more building blocks as time progresses. So how can you use these building blocks if you want to use them from your application? Well, basically, Dapr offers an HTTP or gRPC API that you can use from your application. So if you have a language or some kind of a platform that you can do HTTP request or gRPC request from, then you can use Dapr. So that's basically, any language out there. And of course, that's a pretty nice way of using Dapr, but you have to handle all the HTTP and gRPC communication. So to make that a little bit less cumbersome, there are also some SDKs available. And these SDKs are available for different languages like Java or .NET or for Go. And also these SDKs are completely open source. So there are probably going to be more SDKs as time goes on. If you look at how does Dapr implement this, well, it uses the Sidecar pattern. So basically when you run your application, Dapr will run a sidecar process next to your application. It's a completely separate process. And your application will call the Dapr sidecar over HTTP or gRPC and make use of the building blocks. And it is also not necessary to use all the building blocks that you see here. So you can just pick and choose the building blocks that you need for your situation. So you could only use state management, or you can only use pubs up and don't use any of the other building blocks. So that's pretty awesome. This is a standalone mode, what you see here in this slide. So we're just running two separate processes, but it is also possible to run Dapr sidecar within a pod in a Kubernetes environment. And as you might know, in Kubernetes, if you have multiple containers, because these are Docker containers running in Kubernetes pod, these containers can find each other and can talk to each other over the internal private network. So that's they're pretty close to each other, so you should have less latency because they're running on the same node, basically, in the same machine.
So in the remainder of the session, we want to dive into some of the building blocks, show how they work, and see how they can improve an existing application. And for that application, we are using eShop. Now, eShop is a classic .NET reference application, and it's a web shop that lets you buy cool .NET merchandise and now also Dapr merchandise. And there are different variations of it, but the version that we are using is called eShopOnContainers, which is an implementation based on a microservice architecture using Docker containers. So let's have a look at the architecture. So first of all, you've got this front end, and that consists of a single page application which is written in Angular. And requests from the front end are handled by an application gateway. And that application gateway is implemented using Envoy, which is an open source, high-performance Edge service proxy. And Envoy will route the requests to the backend services. And there are many different backend services in eShop, and they provide the core functionality, such as providing access to the catalog of items, tracking the items in your basket, the ordering process, etc. Now, most calls from the eShop frontend can be directly routed to a single backend service. However, some scenarios require multiple backend services to work together to complete a request from the frontend. And in these cases, a aggregator service is used to mediate that work across those multiple services. And then finally, backend services can also communicate with each other. And this is done using messaging, asynchronous messaging, to keep those services nicely independent and loosely coupled. Now, for the Dapr version of eShop, we've added Dapr sidecars to each of these services. And that makes it possible for us to use the Dapr building blocks. And as you can see here in this graphic, we also added a Dapr sidecar to the Envoy API gateway. So it's not just the .NET services that got a sidecar, but also the Envoy proxy. And that enables us to use the service invocation building block to call the backend services. Okay, so now let's go over to a demo and let me show you that this actually works. Okay, so I'm going over to Visual Studio Code. So I've got a solution opened here in Visual Studio Code. So for example, within the source folder, you can see all the backend services here. So we've got a basket API, the catalog API, and so forth and so further. And we've also got these Docker Compose files, and we can use Docker Compose to very simply spin up all the services and let them run. And you can do that from Visual Studio Code by just going to the command palette and choosing Docker Compose up. But that can take a little while, so I've already done that. And if I go over to the Docker tab here, you can see that all the containers are running. And you can see a mix of the containers hosting the services, for example, the web front end or the aggregator servers, as well as all the Dapr sidecars. So all these containers which are running the Dapr daemon, those are all the sidecars running next to the services. So now with that up and running, I can go to localhost. For Docker, you have to use the host.docker.internal, but it's basically just going to localhost 5104, and that's where my shop is running. So this is the new eShop on Dapr version. And you can see we sell all kinds of cool .NET stuff here, and we've also got these great new Dapr items. And if I want to buy something, so let's say I definitely want this Dapr cap, I can add it to my basket. And right here in the upper right corner, you now see a 1. And if I add, for example, this .NET hoodie, it will turn to a 2 because now I've got 2 items in my basket, right? So let's examine that shopping basket, and you can see that we can also change some quantities here. So you can never have enough Dapr caps, so let's just buy 10 of them. Maybe we get some discount and some hoodies. And then we can go to the checkout. I can enter my shipping address here, enter a payment method, and then just place my order. And after a little while, you can see that my order is now being submitted. You can also see in the top right corner that we received a notification. So eShop uses Signal R to send notifications from the backend to the front end to keep you updated by the process. You can see that we are now awaiting start validation. So what eShop does in the backend is it's simulating this order processing, where we go through a couple of processing steps before the order is completely final. So that is eShop. Now let's go back to the slides. Okay, so now let's look at some of the building blocks that Dapr offers. And we are starting with the service invocation building block. So service invocation enables services to communicate with each other using either HTTP REST or gRPC messages. And we'll also touch on observability a little bit. Now, the version of eShopOnContainers that we based eShop on Dapr on used a mix of HTTP REST and gRPC for service calls. So the simple calls from the API gateway to the backend services are done via HTTP, but they were also experimenting with more high-performance gRPC, so calls from the aggregator servers to the backend services are done over gRPC. So let's look at an interaction between the aggregator and some of the backend services. So when you update your basket in eShop, for example, by adding a new item or updating the quantity of a specific item, that call is going from the front end to through the API gateway to the aggregator servers. And then the aggregator servers first makes a call to the catalog API to retrieve additional information about the items in your basket. And it uses that information to ensure that the updated basket items are still available from the catalog and that they contain the correct price. And after that validation has succeeded, the aggregator server saves the updated shopping basket by calling the basket API. Now for now, let's focus on that second call, on that call from the aggregator to the basket API. So eShopOnContainers uses proto files to generate strongly typed gRPC clients. And in this snippet, you can see that it uses this generated basket client class to make the gRPC call. And then, of course, it also needs to know where the service is hosted. So it stores that address configuration in environment variables. So this is all how it was in eShopOnContainers. So let's now look at how we change this to work with Dapr. So first of all, if you use Dapr, Dapr takes care of service discovery. So instead of directly calling the basket API, the aggregator now makes a call to its local Dapr sidecar. And here I've got an example using an HTTP call, but you can also use gRPC to call the Dapr API on the sidecar. Now, based on the application ID, which in this case is basket-API, the sidecar can do automatic service discovery and forward the request to the sidecar of the basket API service. And that sidecar makes the final request on the actual service. And the response will follow the same path back. Now, this example uses the Dapr HTTP API, but because eShopOnContainers is completely written in C#, and Edwin and I are both C# developers, we wanted to use the Dapr .NET SDK to have a more natural .NET experience. So when you use the .NET SDK, it provides you with a Dapr client class that you can use to call APIs on the sidecar. And this Dapr client class will always use gRPC for that. Now the sidecars also use gRPC to communicate with each other. And then on the callee side, we decided to change eShop back to just HTTP REST. Now, why did we do that? Why didn't we just kept the gRPC endpoint there? Well, because we really couldn't use the eShop protofiles the way that we want to with Dapr. So to let the sidecar call a service of gRPC, you must implement the Dapr protofile. So to handle the service call, we would have to implement this onInvoke method, which is very generic and doesn't give us the natural strongly typed gRPC experience. Now that said, the team is looking into how Dapr can use gRPC reflection to get a better experience here. But the important part is we still get gRPC performance benefits for any calls between sidecars. And from a performance perspective, those are the most important calls because the sidecars may be located on different nodes, whereas the sidecar and the servers are always located on the same node. Okay, let's look at some code. So here I'm back in Visual Studio Code and I've still got my solution open. So let's, for example, have a look at some of the code in the aggregator servers. So there's a basket servers class here, and this basket servers contains the code that I need to write to call the basket API from the aggregator servers. And I want that call to be a service invocation call using Dapr, so I'm using the Dapr client here, which is provided to me from the Dapr .NET SDK. So you can see this method update async, which is used whenever the aggregator service wants to update the basket. And I simply call this single method invoke method async. And I give it the name of the basket API, which is basket-API. And then I also need to give it the method or the route to invoke, which is API/v1/basket. And then I pass in the payload, which is the basket data. And then because the basket API is listening on a HTTP REST endpoint, I can use this HTTP extension object to specify some further details about that HTTP call. So for example, here I need to pass an access token in the authorization header because the basket API is protected and you need to be authorized to update your basket. But there's some other stuff you can configure as well using that HTTP extension object. For example, the HTTP verb, which defaults to post, or the HTTP query string. Okay, so now I'm using Dapr client and I'm using service invocation. So now those sidecars can start collecting telemetry about the calls that I'm making. And I can go to an application such as Zipkin and use that as a sink to view all that telemetry and all that tracing. So now if I run this query in Zipkin, I can see all kinds of tracing that is automatically collected by Dapr about the calls that I'm making. And Zipkin also provides this very nice dependencies graph, which visualizes all the different services in my solution. For example, here you can see that the aggregator service makes those calls to the catalog API and the basket API. So this is some very nice functionality that you basically get for free just by using service invocation building block. So what are some of the benefits that we get from this? Well, and all of these are made possible because now there are these sidecars in the middle in our traffic flow, right? So first of all, the sidecars can inject retry logic. Now if there's a network or connectivity error, Dapr will retry. And I don't have to deal with that myself in my code. And for the future, teams are also looking to expand this with circuit breaker support, giving you even more control. Now, secondly, Dapr gives insights into my application by capturing all kinds of tracing and metrics. And I've showed Zipkin in the demo, but there are other things that you can use, such as Jaeger, Application Insights, Prometheus, and many others. And thirdly, Dapr can secure and encrypt all the communication between the services by automatically using MTLS. And that saves you from a lot of work, like dealing with certificates, CAs, all that stuff. Now let's switch gears a bit and let's look at PubSub. Edwin?
Yes, let's look at publish and subscribe. Publish and subscribe in eShopOnContainers was used to send messages asynchronously between all the services. And for implementing this, there was an event bus abstraction created. And this event bus abstraction was basically used by all the services that needed to implement this or needed to use messaging. Besides the abstraction, there were two implementations created, one for RabbitMQ and one for Azure Service Bus. And you might think why you need two implementations. Well, basically you can then choose to use a different message broker in a different environment. So you can imagine that for development purposes, you might use RabbitMQ, but for production, you might go to Azure Service Bus or whatever you want. So it is a nice thing that you can switch between different implementations of the message broker. But still, because we have two implementations, we also have twice a set of components that we needed to implement ourselves to abstract this event bus abstraction, or to implement this event bus abstraction for all our services. And this is twice the maintenance. And if we think back to the accidental complexity that I talked about at the beginning, this is not what you want, because that's a lot of code that you have to maintain. Also, if you look in the startup class of the services, then you can see that it's quite a lot of code to initialize these service buses of this abstraction. Because you have to first figure out, am I running with Azure Service Bus or am I running with RabbitMQ? And then based on the specific implementation, you also have to know specific implementation details of the specific message broker. And in building these implementations, you also need to know two SDKs, one for RabbitMQ and one for Azure Service Bus. So that's quite complex and you don't want that. Well, this is exactly where Dapr helps, because Dapr has a very nice way of implementing publish and subscribe for your applications. So how does this work? Well, first of all, we've seen this sidecar pattern before. And what you can do from your application, in this case, for instance, the ordering API service, you can just publish a message to the Dapr sidecar. And for this, you can use a well-known endpoint. This is part of the Dapr API that is being supplied by the sidecar. You can just call /publish, and in this case, /order status changed. And order status changed in this case is the topic that you want to send this message to. And because this is an HTTP post request, you can send along the payload of the message. So that's pretty easy. And as you can see, because this is HTTP, you can do this from every language where you can do HTTP communication. So what happens then is that the Dapr sidecar will then use the implementation that you've configured for the message broker that you want to use, and we will look into configuration a little bit later. But it will send this message to the message broker, and the message broker will eventually send it to the sidecar of all the other services that are subscribed to that specific topic. And this sidecar will then in turn call the actual service on a certain endpoint. And this can be all kinds of endpoints. So as you can see here, the catalog API, it says change order status. But on the ordering API, there's order/status change. And we're going to look into how that works in a moment. But this way you can just do PubSub without knowing anything about the message broker that's in between. That's completely abstracted by Dapr. You only use the Dapr API. So, like I said, how does Dapr sidecar know when it receives a message on a certain topic that it needs to call an endpoint on your application? Well, if you're using .NET, then there's a real cool integration with ASP.NET Core. So what you see here is the two different API calls that you saw in the example. So these are just basic ASP.NET Core web API controllers. And they have two methods in this case. So there's a status changed and there's a status update. And what you can do now is that you can decorate these methods with a topic attribute. And this topic attribute comes from the Dapr SDK for .NET. And as you can see here, this is the topic that we just saw in the example. So this way we make a coupling basically between this topic and the individual endpoints on your application. So that's pretty cool, and that's pretty easy. If you use the ASP.NET Core integration, then you need to do another thing, because you need to make sure that your application integrates with Dapr from ASP.NET Core. And for that, there are some convenience methods available that you can use in your startup class. So here we see the startup class of one of these services. And first of all, in the configure services, you can call addControllers.addDapr, and this will basically add the necessary services to dependency injection and integrate Dapr into the MVC pipeline that's being built. And finally, in your configure method, you have a couple of convenience methods to do two things. First of all, you need to specify that you're going to use cloud events. This is a standard-based protocol that you can use for formatting messages. And also, there's a map subscribe handler method available. And what this map subscribe handler does, it basically builds up a structure that says, okay, these are the methods that you have decorated with a topic attribute. So that's the subscription on that topic needs to be coupled to that method. And once your application starts and the Dapr Sidecar starts for your application, it will call a certain endpoint on your application to get this information so it can create the subscriptions on the topic. And this map subscribe handler handles that for you. So you don't have to do anything for that. So I talked about configuration of components before. Well, let's see how you can configure a component. And this goes for almost all the components that we're going to talk about in this session. So first of all, you need a configuration file. And you can specify the configuration file to use when you start the Dapr Sidecar, either using Kubernetes or when you use it in standalone mode. This component file always has a certain name for your component. And this name is very important because using this name, you can specify which component you want to use. Also, all components have a specific type. So in this case, you see pubsub.net streaming. So this is a pubsub component. It is a configuration for the pubsub building block, and it uses net streaming as the message broker. And finally, every component will have specific metadata that it needs, and this specific metadata you can just specify in the configuration file. So by doing this, you can provide which message broker, in this case, the pubsub building block will use to send messages to other systems. So let's look at a demo of pubsub in Dapr. First, I'm going to switch to my Visual Studio Code and show you the configuration file that is being used for the pubsub component in eShop on Dapr. So as you can see here, the name is pubsub and the type is pubsub.redis. So we're using the Redis cache that is deployed with the application as our message broker. And if I go to the Redis Explorer, which looks into this Redis cache, you see that I have all kinds of topics already created in here. So things like order started integration event or user checkout accepted integration event. So these are topics that all parts of the applications are listening to. So if I now go to the application and I order, for instance, the blue.NET hoodie, and I check it out, then all kinds of events start flying around. So first of all, you see that the order is added with the status submitted, but with some intervals you will see this status being changed, and that is all done in the background by a background worker that emits events when the status of an order is updated. So if we now go back and we go to the Redis cache and we take, for instance, the user checkout accepted integration event, if we open that topic, we can see that there's an event in here. So you see all kinds of data. This is just JSON data. We won't go into what is in these events now, but you can see that these are stored in the Redis cache and then forwarded to all the services that are subscribed to these events. So this is basically how pubsub works with Redis as the intermediary message broker. If we now go back, you see that the status is eventually validated and then it becomes paid. So all the backend services are using events to, they're completely loosely coupled, but they work together by sending messages to each other. So that's pretty cool.
Okay, so state management provides a key value based API for persisting state, and you can use it to create stateful services. If you look at the original eShopOnContainers, it uses a variety of data stores. Many services simply use SQL Server and they use Entity Framework to access the database. And that's fine. I mean, it's storing relational data, and NT Framework is very good at that. And NT Framework also already provides support for many different databases, such as SQL Server, MySQL, Cosmos DB. So that already gives us portability for relational data. But there are also some other services that use different data stores. So for example, the basket microservice stores the basket state in a Redis cache. And to make that work, eShop has a direct dependency on a NuGet package called stackexchange.redis, which is a Redis client for .NET developed by Stack Exchange. And we can make that service a little bit more portable by removing that dependency and using the state management building block of Dapr. So with Dapr state management, you can store and load state in a key value store by simply making calls again to the sidecar. So let's say we want to store the basket. We can simply make a post call to this state API endpoint on the sidecar. And we need to pass it a JSON message which contains the key under which we want to store the value and the actual value to store. And then Dapr uses its configured components, for example, Redis, but you can also use Cassandra, Cosmos DB, Azure Table Storage. There's a really large list of components to choose from. And it uses that component to persist the state. And then when we want to read the stored state again, we again simply make a call to the sidecar. This time we do a HTTP GET. We give it the name of the state store and the key of the state entry to get, and we get back the value. So let me show this in a demo. I'm going to pull up Visual Studio Code again. So eShop uses the repository pattern to access data stores. So for example, inside the basket servers, there's this basket repository class, which is responsible for loading and saving the basket data. And when we change this to use Dapr, we change the implementation to use, again, the Dapr client. And as you can see, that API is really simple. So the Dapr client gives us methods for loading state using this getState method. It also allows us to save state. For example, here we are loading a piece of state from the data store. We are updating it, and then we are saving it back using this call to save async. So a really simple API. Now, the type of data store that is used to persist that data, that is stored in a component configuration file. So let me look that up. And you can see that here. So this is the same kind of component configuration files that Edwin showed you earlier, only this time it's for a state component, and it specifies a configuration for Azure Table Storage. So I'm storing the basket state inside of an Azure Table Storage table. And of course, I need to give it some connection details so that Dapr knows how to connect to table storage. So I need to give it an account name as well as an account key. Now, obviously, I don't really want to store any secrets inside this file, right? This configuration file will end up in source control, and we don't want any connection strings there. So instead of specifying the connection string directly, I'm using another Dapr building block, which is the secrets building block. So what I'm doing here is I'm telling Dapr for the account key, just go look inside the secret store for a secret named storage account key, and then use that value as the actual account key. So in the secret store I've named it Azure Key Vault because I'm using an Azure Key Vault, and that is stored in a different component configuration file. So this configuration specifies a config of type secret stores.azure.keyvault, and again I need to give it some information on how to connect to that Azure Key Vault. Now, unfortunately, in my case, I do have to have some way of specifying a secret or a password to connect to that key vault. And we've done it using a certificate. So this PFX file here contains the actual credentials to connect to the key vault. And you can just choose to not store that inside of source control, but you have to manage it some way. Now, fortunately, if you're running on Azure Kubernetes servers in production, then you can use managed identity to connect to Azure Key Vault, and you don't have this problem at all. Okay, so let's switch over to the Azure portal and have a quick look at the Azure Key Vault. So this is my Azure Key Vault, and as you can see, I've got two secrets set up in here. I've got this foo secret, and I've got this storage account key, which is used for the basket. And now I can very simply, by just doing an HTTP request, I can use the secrets API from a Dapr Sidecar to access that foo secret. So if I do a curl request to the Dapr Sidecar, use the secrets, use Azure Key Vault because that's the name of my secret store, and then use foo because that's the key of the secret, then I should get back my very secret value bar. So that just shows you that, that this works and that it's really simple to access those secrets once you've got that configuration all set up. Okay, so now everything is set up to store that basket data in Azure Table Storage. So let me go back to the Azure portal and let's go over to my storage account. And here you can see the basket table where all the basket data should end up. And just to show you that it's really empty, I'm going to refresh this. So there's no basket data stored right now in Azure Table Storage. Now that means that if I go over to the eShop, that there shouldn't be anything in my basket now. And that's correct because that basket number is at 0. So let's add an item. Let's go with the mug this time. So I'm adding that to my basket. You can see it's increased by 1. So now if I go back to my storage account and refresh this table here, now we see the state that's being stored by Dapr inside that storage account. So there you have it, Dapr State Management with Azure Table Storage. Okay, so let's go back to the slides. So Dapr already has this very nice list of supported state components, right? So now your application can use all of these stores without adding or learning a third-party SDK. So that's very nice. And as you can see, the state API also supports transactions, but only for a selected number of components. And there are other subtle differences between stores. So for example, if a string stored in table storage, right, that has a maximum of 32,000 characters. Now, if you're switching from a store that doesn't have that limit, and you are trying to store strings which are larger than that, then maybe now your application fails because your selected store cannot store that amount of data. So while you do gain a lot of portability with this layer of abstraction, you still need to pay really close attention to the details of the various components that you use. So that's it for state management. Let's move over now to a very cool feature of Dapr called bindings.
Yes, resource binding and triggers. So let's look at that building block. Well, first of all, resource bindings are a way to integrate with different external systems. And this is a bit of an abstract term, of course, and you could say that publish subscribe is also, of course, a way to integrate with different external systems. But resource binding do not focus specifically on message brokers like Azure Service Bus or RabbitMQ. There are, for instance, resource bindings for Twitter and Twilio SendGrid and Azure Storage. So also different kinds of systems you can integrate with using resource bindings. There are basically two types of bindings that are input bindings, or triggers as they are called, and they can react to events that happen in these external systems and then invoke your application. Output bindings are called by your application to integrate with an external system, and you do this as we've seen with other building blocks, just using HTTP or gRPC, and then you send this message to the external system. So let's see how that works in a diagram form. So first of all, we have a service that is running, and it has a Dapr sidecar, and we're looking now at the input binding, so the trigger. So what happens first is the Dapr sidecar will receive a configuration for a binding. In this case, it's the Twitter binding. And as we saw before with other components, you can give it a name. In this case, the name is tweet, and this is important for this scenario. And we see that this is a bindings.twitter binding, and it has some metadata for connecting with the Twitter API. If this configuration is read by Dapr, it will connect to the Twitter API. So it knows how to connect to it and then starts listening for certain tweets. And if you look in the configuration file, there's a query field in there that we're looking for tweets that contain the text Dapr. So now, every time a tweet is published to Twitter with Dapr in the text, this will be picked up by the Dapr sidecar. It will be sent to the Dapr sidecar, and it will invoke your application on a certain endpoint. And in this case, it is the endpoint/tweet, which is basically the same as the name of the binding that you configured in the configuration file. And then the service will get this invocation. It will get the payload with the tweet information, so it can handle that. And then the service will return a 200 OK if it handled this tweet correctly. And then the Dapr sidecar knows that this binding invocation has been handled successfully. So this is how input binding work. For output bindings, it's a little bit different. So again, we have here the service, it's now on the left, and we have the Dapr sidecar that is started with the service. And the Dapr sidecar will get the configuration for the output binding in this case. And here we see where I'm using the Twilio SendGrid binding for sending email. The name is SendMail. Now, if we want to send an email from our application, from our service, we can invoke the Dapr sidecar on the API. So in this case, /bindings/sendMail. And this sendMail will eventually determine which binding to use for sending this email. And again, this is a post, so you can send in the payload of the message. There are some fields that you need for sending the email. So basically, where does the email come from? To which email address do I want to send it? What is the subject, etc. And also the body, of course, of the email is in there. What happens when you call this API? The Dapr sidecar will use, in this case, the SendGrid component for the output binding, and it will send the email to SendGrid. And this way, you can integrate sending email in your application without knowing anything about the SendGrid API or even how to send an email. You just do an HTTP request. And once the email has been sent to SendGrid, the Dapr sidecar will reply with a 200 OK, so you know that everything is well. So this is how input and output bindings work. Some bindings can also be bidirectional, so you can use them as an input as well as an output binding, and you have to figure out, using the documentation, what the capabilities are of all the different bindings that are available. A really cool thing to mention, by the way, is that all bindings, and actually all the components that implement building blocks for Dapr, are completely open source, and you can contribute to them. So you can build your own bindings for your own external systems if you would like.
So the big question is, does all of this improve eShop on containers? Now there's a lot going on in eShop, and certainly Dapr helps by reducing the number of different frameworks that you have to deal with. And I think that you can especially save a lot of project startup time if you're in a greenfield scenario and you are about to build a new distributed system using Dapr. So one of the things is that Dapr can really help you reduce the amount of code that you have to write manually. In eShop, this is particularly clear if you look at the pub subcode before and after the Dapr rewrite. And then you can also get some features basically for free, like the distributed tracing that we showed in Zipkin. Dapr also greatly increases the portability and interoperability of your system. If you again look at eShop, it supported two pub subsystems, RabbitMQ and Azure Service Bus. Now in the Dapr version, I can choose from a whole lot more just by changing some configuration. And that flexibility also allows you to defer infrastructure decisions to a later point in the project, which can also be very valuable in and of itself. And then on the point of interoperability, eShop is of course completely built on .NET. But now with eShop on Dapr, I can easily add microservices written in any other language, Python, Java, whatever your favorite language is, and then use the exact same building blocks as we're already using from our C# services. So that the fact that Dapr really runs with any language, with any framework, is really valuable. Now do take note that Dapr is not in production ready yet, it's still in preview. There are definitely sometimes breaking changes between versions, but that is to be expected. However, we should be in the release candidate phase now when you're seeing this, and a 1.0 version is expected early next year, probably February. So Dapr will not be a silver bullet that solves everything, but we do believe that it's a very useful tool to have that makes building distributed systems that much easier. There's also a really active community around Dapr, so we're really interested to see where the project will go in the future.
So that was our session about Dapr. Thank you for watching, and we hope you learned something about Dapr and maybe even became interested in using it in your microservices application. Like I said, thanks for watching. If you want to reach us, you can see our Twitter handles over here. Also, if you want to know more about Dapr, check out the website dapr.io or the brand new documentation site docs.dapr.io. There's also the code for eShop on Dapr that you see here. There's a GitHub link to it. And if you want to watch more videos of us, also with guests and guest speakers, then go to our YouTube channel .netflix on youtube.com/.netflix. Thanks again for watching, and I hope you have a great conference.